sometimes when you fit an exponential curve, a linear curve, and a power curve to data, it's not clear which is the best fit. So how can you determine what's the best fit? For example, here we have 5 years of Staples revenue, 1997 through 2001, labeled year 1 through year 5. Here's the revenue. We fit the exponential curve. You can see it's a pretty good fit. We fit the straight line curve. It's a pretty good fit. We fit the power curve. Pretty good fit. How do we determine which is formally the best fitting curve? Well, we find the prediction for each curve and see which is the most accurate. And I use absolute percentage error. Okay, so basically for each year and for each curve, you take what percent you're off by, which is the actual minus the predicted divided by the actual with an absolute value sign. And then whatever curve has the minimum MAPE, mean absolute percentage error, would be the curve I would use as the one that best fit the data. That doesn't mean necessarily it would forecast the best going forward, but it's the one that best fits the data. So how would I find the prediction? For the exponential, take 3143.3 times e to the 0.2551 times the year number. Copy it down. For the linear, take 1747.3 times the year number plus 1955.7. For the power curve, 3706.8, that's right there, times the year number to the 0.627. Okay. The caret means to raise to the power. So those are my forecasts. Now, what's the absolute percentage error? We take one formula in L6 and copy it down and across. Take the actual Staples revenue, $ the column, so when you copy it across, you still pull that column, but don't $ the row. So when you copy it down, the year will change. Subtract off the forecast. There you want the row and column to change. And divide by basically the Staples revenue, fixing dollar with the $ column H, but not row 6. You want that to change to 7. So this would be, for example, 10874 minus 11254 divided by 10874, off by about 380 out of 10874. That's about 3.4%. And then when I come here, it's Staples revenue 3968 minus the power prediction 3706. We're off by 260 out of 3968. That's 260 out of roughly 4,000, about 6.5%. So then you have the absolute percentage error for every year for each curve, and you average those. Here's the average for the exponential, the average for the linear MAPE, mean absolute percentage error, average for the power, and then the exponential curve does better. Okay, so basically it's off by an average of 2.7%, the linear 3.1%, the power 5.4%. So here I would go with the exponential growth curve as the curve that best fit the data. Now that doesn't necessarily mean it's the best at forecasting the future, and we'd have to have a lot more data to try and figure that out. We would use what the curve was fit up to a given year, and then what happened next year, and do that for every year for every curve and see what does the best. But that's a little bit more involved than we want to get here.
Okay, so thanks for watching, and there's a free course, a free 21-day course from Dr. Winston, and all of these videos are coming from one of 3 books. So first, this one, which you can see here at the top of the screen, Microsoft's book, which has 355 reviews, and then it's, let's see, 4.6 stars. It's coming from this book as well, his marketing analytics book, which is down here, and you can sort of see 4.5, or his newest book, his analytics stories book, which is here. And with that one, you can see it's 4 point something, or maybe even 5. I don't think it's 5. Yeah, 4.8. And so, yeah, anyways, in the description, there's a free 21-day course from Dr. Winston, or you can go to excelwithwayne.com/free, and it'll be there. But again, thanks for watching, and if you have any questions, just please let us know. Thanks.